Achema Pulse is always about technology and how can technology help us achieve what we are aiming for. So let's talk about 5G, one of the key technologies in the digital transformation. And we now have Dr. Andreas Mueller telling us about the state of 5G. He's head of communication and network technology in the corporate research department for Bosch in Stuttgart. He's also coordinating Bosch's industrial 5G activities across the different business units and serves as chairman of the board of the 5G Alliance for Connected Industries and Automation, ACIA, which has been established for driving, shaping, and promoting industrial 5G worldwide. And Dr. Mueller will now give us an overview of the 5G ACIA and its activities with a focus especially on the process industry.
Yeah, hello everyone, and thanks for the kind introduction, and thanks for having me here at Achema Pulse this year. It's really a pleasure to be part of this interesting event. As has been said already, 5G certainly is a key technology for the digital transformation, not just of the process industry and the manufacturing industry, but of our entire economy and society. And I'm here primarily my role as the general chair of 5G ACIA, the 5G Alliance for Connected Industries and Automation. It has also been mentioned, which has been established a couple of years back for bringing all relevant stakeholders together in order to jointly shape and drive 5G, especially for the industrial domain, for the process industries, and also discrete manufacturing. And it's a particular pleasure to be part of this year's Achema Pulse, because we also gave a couple of presentations, and there was also a panel discussion at the last Achema in 2018. So at that time, of course, it was still a face-to-face event in Frankfurt. And at that time, we were at the very beginning of the industrial 5G journey. So we just have established 5G ACIA. People from the industrial domain got more and more interested in 5G. 5G was not a reality yet. So this was a starting point. And today, it's a pleasure to be back and to give an update on where we currently are on the industrial 5G journey. And I just called it here the State of the Union address, basically, on industrial 5G. So we'll really go through different topics, touch different topics so that you get a rough feeling what has happened since then and where we currently are. Hopefully this is interesting for you. And if there is a need then or an interest to deep dive into some topics, you can always reach out to us, either to myself or to any other colleague in 5G ACIA to have some deep dive discussions here. So let's start with the fundamentals first. So a brief recap, why is there actually such a high interest in 5G in the industrial domain? And it's pretty simple. So we have the developments towards 5G, but 5G is not just the evolution of 4G, it's more a revolution. And that's because the previous generations of mobile communications always were concerned about connecting phones, connecting people. In one way or the other, the phones got better over time, but still it was about connecting phones primarily. With 5G, this changes because from the very beginning, 5G had a very strong focus on connecting all kinds of things in the Internet of Things, on enabling completely new applications in these different vertical domains, manufacturing, industrial production being one of them, but also in the automotive industry, in agriculture, and healthcare, and so on. In all these areas, 5G will play a very important role in future. At the same time, and it started independently of 5G, of course, we have the developments towards Industry 4.0. It's all about merging the physical world of production with the virtual cyber world of the IT industry. And connectivity per se is a key enabling technology for that in order to realize a vertical and horizontal integration. And now it's rather straightforward to bring these two major developments, which started independently of each other together. So to use 5G in a factory, in a plant, in order to lift Industry 4.0 to the next level and to achieve unprecedented levels of flexibility, efficiency, productivity, and also ease of use so that we can support the people working on site in a very intuitive and ergonomic manner. So that's the high-level vision. if we look a little bit into more detail, what can be done with 5G in the industrial domain, I've outlined here a couple of use case categories. Of course, it's a natural choice if you want to connect mobile or portable assets, be it automated guided vehicles, be it forklifts, or also some tools that you want to carry around. Also, if we connect moving or rotating parts in the packaging machine, for instance, where we're using slip rings today, track chains, and similar things, so this can be replaced then using 5G. Wireless sensors is a big topic, and especially in the process industry, of course, we have many sensors, we have large distances that need to be bridged, we have harsh environments. So also here, wireless is a natural choice. There were attempts in the past with wireless HART and so on to have some wireless solutions supporting these use cases in a good way, but to be honest, they never really found a widespread adoption in the process industry. And 5G now has the potential to change this due to the capabilities that 5G comes along with. So it's not just higher data rates, it's also low latency, high reliability, high availability. And also, of course, it's not a niche solution. It's coming from the mainstream market, but we still can use it also for many industrial applications. Then also human-machine interaction, I mentioned this already, augmented reality, virtual reality, so that we have remote support use cases, for example, or that we can monitor a process plant using AR headsets. Positioning and tracking is a very important category as well, because we can use a 5G network, not just for connecting devices, but also for locating devices. And this with the very same infrastructure. It means we don't have to deploy a separate positioning system in case that we would like to locate certain nodes. Modular production, so that we can really have build up a factory like Lego bricks, easily connect different modules in order to reconfigure a factory, for example. Retrofitting, of course, a very big topic. If you want to upgrade existing machines, existing facilities by deploying sensors and whatever, then we don't have to worry about the cabling, at least not the cabling for the communication, which is a big benefit. We can just put the sensor somewhere, maybe driven by a battery, and connect it to the 5G network, and then we are done. And of course, one of the biggest benefits from my perspective is the large flexibility, the high flexibility and versatility of a 5G network, which has the potential to really become a one-size-fits-all solution, at least for all these wireless applications that we have in mind, so that we don't need different technologies for different use cases, but only one system, namely 5G in future, that can support all of them. And that, of course, is then helpful in reducing the complexity and eventually also the total costs of ownership. So here again, one slide, what 5G ACI is about. I briefly mentioned this already. It really serves as a global forum for the ICT industry on the one hand, and the OT industry, the operational technology industry on the other hand. This includes, of course, manufacturers, it includes machine builders, but also then the companies providing solutions and components for industrial automation. And we always have a look at both the process industry and also discrete manufacturing. And these are different things then that need to be addressed. So it starts with the establishment of a common language. We make sure that the needs of the industrial domain are reflected in standardization and regulation. Not too many industrial players are a member of 3GPP, where 5G is being specified. But it's very important that 3GPP understands what we want to do with 5G and what the constraints and special challenges are in an industrial environment. So therefore, we need this bridge to standardization here. We're also jointly discussing how we can optimally make use of 5G in the industrial domain. We are now checking certification needs, testing needs, and of course, it's also a lot about ecosystem building and promotion of industrial 5G worldwide. We started in 2018, so we had a kickoff event at Hannover Messe in April 2018. And we started with 26 members. As of today, we are 85 members, so we really have seen a significant growth over the last 3 years. You can see an overview of our current members. It's really a good mixture between ICT industry, OT industry, and also some academic contributors, and also a good mixture from different geographies around the world. And we keep on growing, so stay tuned. And next month, we will be happy to announce a couple of more members who already signed the paperwork, and among them also some heavyweights in the industry. So where are we today? Maybe that's more interesting, at least if you have already heard about 5G before and industrial 5G. So today, 5G in principle is a reality. So you can go to a shop, you can buy a 5G smartphone, the networks are being upgraded to support 5G. We already have a decent coverage in Germany and also other countries. But what we have today is basically consumer 5G. So that's more the evolutionary path, supporting higher data rates on a smartphone, to simplify things a little bit. At the same time, the business potential of this evolutionary path is limited. So it's more a must do. Otherwise, maybe a network operator will lose customers because they expect that they can always get access to the latest technologies. But it's maybe not a way, especially for the ICT industry, to really significantly increase revenues because customers are not willing to pay more. At least it's the case if I look at myself and others as well. If we look at now industrial 5G, so then it's a little bit different. Of course, this is more revolutionary. There is no history in the widespread usage of mobile communications in the industrial domain. It's something new, which comes along with many specific challenges. So therefore, there is still some work to be done to make to really achieve the industrial 5G vision. But if we do so then there's a significant potential for all stakeholders basically in the market, significant potential for the ICT industry to increase revenues, to sell more modules, more infrastructure components, and so on. But of course, and then maybe that's even more important also for the industrial domain, to really increase the flexibility, the productivity, efficiency, and so on, as I mentioned before. But a key message here is there is still work to be done towards industrial 5G. It's not a reality in many cases yet, but we are working on it, and it's very confident that in the next 1, 2, 3 years, this will significantly change because there are good reasons why we are not there yet. So first of all, we started later. Mentioned this at the last Achema. Basically, this was the first time that you could hear about industrial 5G and 5G ECIA at such an event, whereas the ICT industry already started in 2012. Some of the key features which really make a difference to the industrial domain will only be available with the next versions of the standard, the next releases. So I'm thinking about ultra-reliable low latency communication, this URLLC, support for time-sensitive networking, the next generation industrial Ethernet, and also this reduced capability mode, NR-RedCap, which might be a particularly attractive solution, especially for sensors and actuators in the process industry, for example. So it's not such a high-end mode than what you have in your smartphone, but still capable enough to satisfy many of the requirements that we have here. So also then there are other needs necessary in the ecosystem, new operating models, new business models. Mobile communications traditionally was a B2C business. Now it's getting B2B. That comes along with necessary adjustments of the business models. Performance validation is still ongoing. Of course, if you want to use 5G in your facilities, then you don't want to just trust some simulation results that somebody has prepared. You really want to see it in a real-world environment with all the metal, all the challenges that we have, that you get the performance that it promises, and that's still ongoing. There are more and more trials and test beds going on. We have different innovation cycles, of course, and the process industry here is maybe really an extreme example. The ICT industry is used to have new versions of products, of standards every 2 years. In the process industry, it's more 10, 15, or 20 years. And somehow we need to adjust these different speeds here. Then the ecosystem has to grow from scratch, which takes time. And also we have a chicken egg challenge. The question is, will we first of all see facilities equipped with a 5G network, or we will first of all see industrial 5G components coming up? Someone has to make the first move, and then the whole developments are taking off, and the ball gets rolling, basically. So what have we done in 5G ECIA? And now I want to touch different topics and just give you a little bit of an impression of where we currently are. So we have done a lot of work on use cases and requirements. We have analyzed them in 5G ECIA. We have published parts of it in some white papers that you can also download from our website. And of course, we have brought them to 3GPP. There are many documents now, like this technical report in 3GPP, where many of the use cases and requirements are well documented. And it really covers the whole area, so intralogistics, discrete manufacturing, of course, also the process industry, monitoring, things like this, and then also augmented reality and similar applications. So we really try to cover all the possible use cases and applications that we see at least, but there are always new things coming up. 5G SAA also has been a market representation partner of 3GPP since 2018. So November 2018, we became an MRP, as we say. And with that, we are basically the official voice of the automation industry towards 3GPP and the other way around. So very close collaboration with them. And if you look now at the standardization timeline in 3GPP, so that's important to understand a little bit what I mentioned before, that some things are still missing. What we have today, if we talk about 5G, that's called Release 15. That's the first version of the standard that has the 5G label. And it still had a strong focus on enhanced mobile broadband, so high data rates. Now it's getting interesting for industrial domain with Release 16 and Release 17. Release 16 is already available, but now the features have to be implemented and to be tested. First chipsets have been announced already, but we're still waiting then modules and also infrastructure components supporting this. And they will have many of the things that are really attractive for the industrial domain. I mentioned this already. And Release 17 is then the next version, which is currently being finalized. And there we will see enhancements of many of the things that have been introduced in Release 16, but also new features like this reduced capability modes, NR RedCap, and also better support for positioning with a target accuracy of 20 to 30 centimeters. And then, I mean, this is always a permanent cycle. So then Release 18 is already coming up at the horizon. It's currently being discussed then what should be in scope for the next version of the standard. And it's also something that we are then shaping with 5G SAA, that we provide input to corresponding discussions. And we try to make sure that they pick the right topics that really provide value to the industry domain. So another important topic, and I guess many people already have heard about this, are the so-called non-public networks. Some also say private networks or campus networks. And this is also driven a lot by many industrial players, because if we are thinking about using 5G in a factory, in a plant for the process industry, of course there are concerns about security. Do I have to give my data away? Concerns about performance. Do I really get the performance that I need? Can I configure the network in the way that I need? Isolation, that we want to be independent of what happens around us. And also questions regarding liability. What happens if something goes wrong? How easily can I determine whose fault it was and who is willing to take liability for that? And these were major drivers for this concept of non-public networks. A non-public network is a standard compliant network, but not meant for the general public, more for a restricted set of users, for example, sensors and actuators and AR headsets in a factory. And we are always talking typically about local deployments inside a factory, for example, but also in other domains, could be a construction site or could be hospital. And also here we've done a lot of work in 5G SAA, driving these developments, but then also analyzing different flavors of non-public networks, because as always, the world is not black and white. It's not either using a public network or doing everything on your own. I mean, that's one viable option, but there are also other options how to set up such a private network with different levels of collaboration with an established network operator, for example. You could say I have one radio access network, so I use the base stations for both the public and the private network, but for the private traffic from originating from my sensors and actuators, for example, I then have a local breakout, so that still the data does not leave the factory, basically. And this depends then on the company, on the interest, the level of expertise, and so on is available, what the best and optimal solution would be. From my personal perspective, we really will see a wide variety of different flavors here in the market. And also here we've published a nice white paper summarizing this and evaluating this a bit in more detail. Then another recent development, which is extremely important for the industrial domain at large, is the support for time-sensitive networking. We have the developments towards TSN currently happening in the wired domain, so that we can get over this field bus war, that we can get rid of this wide variety of different industrial Ethernet technologies that we have today. In the future, hopefully only TSN. And the nice thing is now that 3GPP has picked up these developments and a 5G system, which by itself can be a rather complex thing, but it supports then the basic APIs and interfaces, so that a complete 5G system appears like a big virtual TSN bridge to the outside world. And it's depicted here a little bit. So in light blue, you can see basically a 5G system on an abstract level. UE is the user equipment, the end device, the G node B is the base station, and UPF is the user plane function, basically the gateway to a data network. And then in 3GPP, they have specified these translators, TSN translators on the device side and the network side. And then from the outside world, as I just said, this appears like a big virtual TSN bridge. And that's very powerful because it allows for a very easy integration and a seamless migration towards 5G. And here you can see some of the protocols and the mechanisms that are supported by the standards, time synchronization based on 802.1 AS, for example, redundancy, but also bridge configurations with traffic scheduling and so on. So especially those building blocks of TSN that really are important for the industrial domain. What we also did is then, if you deploy a 5G network in your facilities, you most likely want to integrate this in your existing IT infrastructure, in your enterprise IT, and also have it interwork with your industrial IoT applications. And of course, here there's a need to make this also as simple and as smooth as possible. So the traditional interfaces that a cellular network has, they come from the telco domain. This can be rather complex interfaces because a network operator and so on can well deal with this. But if you integrate this in your enterprise IT, of course, we have existing ways how to manage IT networks and IT infrastructures. And so therefore, there are specific needs so that this can be done in a simple and easy way. And this is what we've analyzed. So what capabilities, what functions should be exposed via 5G system so that it's very easy to access required capabilities, to manage them, and also to monitor the network status, for example. And this can be device-centric functionalities, for example, the identity of a device, location management, or provisioning of devices, but can also be network-centric capabilities and features, for example, that we can monitor or configure the network. And also this is something, again, that we have summarized in a white paper that we have published recently. So what we generally see with the developments towards the industrial IoT and Industry 4.0 is, of course, digital twins, a very big topic. And related to this, the asset administration shells. So that's something that is coming from the industrial domain. And if you're now thinking about using a 5G network in the industrial domain, of course, we have to think about, do we also need asset administration shells for the 5G system? And we analyzed this and we came to the conclusion that this would be very beneficial, but we should distinguish between an asset administration shell for the 5G network and for the end devices, the user equipment, or also called UE in the standards. And this is then something we analyzed in more detail. So we thought about use cases, what you can do with it, and also what such asset administration shells could look like or should look like. Again, this has been published again in a white paper. You can see one picture out that I've taken out of it. Of course, there are different ways how to model this and how to represent the asset administration shell. And here now are two principal examples for an AAS for the user equipment, the end device, and the network. So for the user equipment, it could be things like the certification status, the equipment identifier, but also the connectivity quality of service requirements. And that's very good because if you then integrate a device that has such an asset administration shell in your network, then the network automatically can learn the requirements from the corresponding information in the asset administration shell, and ideally then automatically configure the network in such a way that this is optimally supported, so that it's really getting plug and play. And these are kind of the use cases we have in mind. Some others are mentioned here, and even more are then outlined in the corresponding white paper. Security is another big topic, of course, and there are special ways how to deal with security in the industrial domain. We have IEC 62443, for instance, which introduces and specifies the concept of zones and conduits, depicted here a little bit. I guess many people in the audience might be familiar with this. And the question is now, if I, again, integrate a 5G network in such an architecture, such infrastructure, how do I do that? Where do I place the base station? In which zones? Where do I place the core network? Do I place it maybe at one spot? Do I maybe distribute functionality? So these are things we have to think about. And also then, how do we bring established ways of doing security together? For example, in mobile communications, we have SIM cards traditionally. So what does this mean if I use such a device with a SIM card in an industrial setting, or is it better maybe to use seamless authentication? Also, this is something that has been driven by many industrial players, so that maybe we can reuse authentication mechanisms that we have in use in the factory anyway. And also here, the interested reader is referred to a special white paper that we've published. Performance testing, another important topic. As I said before, performance validation is the starting point, that we establish trust in technology, that we really are sure that it provides the performance that we want to have. But the question is then, how do I actually do that? So how do I test the performance of a system? And ideally, I do it in such a way that I can get reproducible results. So if I test it today and test it again in 5 days, I should get the same output if I do the same tests. And also that we can get comparable results, so that different stakeholders can run tests and we can compare them, and we say, in this case, we have a better performance than in the other one, and then we can start discussing why is it like this, and how can we basically optimally configure the system. And also here, this is something we have extensively analyzed and worked on in 5G SAE. So on a high level, it looks like this, that we have a system under test, for example, a plant with a 5G network. We have to specify then, of course, the baseline parameters, how to configure the system, and basically some stimuli, for example. And then we measure some performance parameters and we analyze them, and then we get the actual performance testing results. So on that level, it looks very easy. But the question is really, what baseline parameters do I have to configure, in what way? How do I actually measure things? If I talk about latencies, I always have to say between which points I measure latency and so on. And all these things need to be clarified. And again, something we have extensively done in 5G SAE. And this is then also the basis, basically, for the 5G SAE testbeds that we have launched now. So we have worked on a framework for 5G SAE testbeds. Different members basically can get together and do some hands-on testing of 5G, build up some testbed, and ideally they do it based on our performance evaluation framework, so that we really get comparable results from different testbeds. So far, as of today, we've approved 4 testbeds, which I have on the next slide. We will have another major plenary meeting next week. Most likely, we will approve 2 or 3 additional ones, and there might be more testbeds coming up in future. And that's certainly something of high interest in general, because here we're not just talking about things with PowerPoint slides, as I'm doing it right now, but you can really see then 5G in action. So I'm running a bit off time, that's why I keep it a bit short. So here you can see the first testbed. This is driven by ABB Ericsson as part of a European research project, 5G Smart. They are considering robotics a lot, collaborative robotics, but also human-robot collaboration, supported by machine vision, by cameras, and also then augmented reality. And the unique thing is, devices are connected using 5G, but then we have intelligence shifted to a local cloud, so that we close control loops in many cases over the air. And it's something you would not necessarily want to do with existing wireless technologies. There's another major testbed in Aachen at the 5G Industry Campus Europe, so run by Ericsson and Fraunhofer IPT. And they're doing adaptive machining with acoustic emission sensors. So it's more sensor connectivity, and also a multi-sensor platform for production process monitoring. But there are many more things going on in Aachen, so that's just the tip of the iceberg, and more things coming up soon. And then we have 2 additional ones here, one mainly run by Huawei in Munich. They are combining AI with 5G and edge computing, for example, for mobile quality control, that you can do quality inspections during transportation of goods. So then transport time becomes value creation time, preventive maintenance. So with a combination of of artificial intelligence, augmented reality, and edge computing, and also safety and security related aspects. And then the last one that's run by Bosch. So one I know very well, together with Ericsson in Reutlingen. So there we have our original semiconductor factory. Recently, of course, we just launched a new one in Dresden. But also there we've deployed a 5G network in order to investigate the potential of 5G in semiconductor manufacturing. And there are 2 main use cases. One is also the cloudification of automated guided vehicle functions, so that we shift intelligence to the edge cloud, close the control loop over the air. And the other one is time-sensitive networking over 5G. And there are some nice videos available for all of them. In the interest of time, I can just show one, and this is what we want to do now. And here we would like to briefly show a video that we have taken in the plant in Reutlingen, which gives you a little bit impression of what we are doing there and what it looks like. So with that, let's have a look at the video.
5G Smart is a collaborative EU project with a goal of showing how 5G can boost smart manufacturing.
5G is getting a really interesting technology. It will connect things in the Internet of Things. And that's why it will help us to automate our plants. Also our semiconductors and sensor plants here in Reutlingen and the one in Dresden, the new one.
In 5G Smart, we want to investigate the challenges but also the opportunities that 5G brings in a production facility. Therefore, we have installed an Ericsson 5G network at Bosch inside their fully operational semiconductor factory. Transportation is an essential part of production in any high-tech factory. At the Reutlingen factory, material transport is partially or fully automated. Driverless mobile robots support the workers on the factory floor. With 5G, robot control can be moved to the edge cloud. In the 5G Smart project, we're taking the robot cloudification to its extreme. We have developed a research robot for which we have moved the entire control stack into the cloud.
Another use case is about TSN and industrial LAN. We want to see how we can connect our production equipments to the Bosch network and how we can control the production equipments via 5G instead of copper in terms of speed, data volume, stability and performance.
At the trial site in Reutlingen, we're working together to demonstrate and validate the impact of 5G for new manufacturing use cases. Our close collaboration opens up for new ideas, research topics, and solutions.
The importance really with the collaboration with Bosch here is the possibility to do this in a fully operational factory floor. So we have this 24/7 operation. And with that will give us a lot of real-life learnings.
All right, so this was a short summary basically of what we are doing here in Reutlingen as part of this 5G ACIA testbed. As I mentioned before, feel free to visit our website. So there we have similar videos also for the other testbeds. And there's more exciting stuff to come soon. Probably next week, we have the next testbeds approved. I have to speed up a bit. We are also, of course, trying in 5G ACIA to closely align our activities with other initiatives around the globe. So we don't want to reinvent the wheel. And on the other hand, we want to make sure that whatever we are working on optimally fits to other important building blocks. That's why we have this global partner network with existing collaborations with all the organizations that you can see here. Most recently, for example, we signed an MOU with the OPC Foundation so that we also bring OPC UA optimally together with 5G. But we also have partnerships with 5G initiatives in India and China and Japan and the Industrial Internet Consortium, to highlight just a few here. This is a brief overview of some other topics where I don't want to go into more detail. I mentioned OPC UA and 5G integration. We have made a comparison between 5G and Wi-Fi 6. What are the pros and cons of each technology? We are very much looking now into the device architecture and device requirements. And this is just a snapshot of many interesting things we are currently working on. Now, that's where we currently are, but of course, there's still some challenges that need to be overcome. And also, we already started a little bit looking into the long-term development of 5G. First of all, ongoing challenges. I mentioned and touched already some of these aspects. So the reason why we don't have 5G in industrial 5G in reality yet is because many of the features still need to be implemented. So here, maybe we just have to wait. The first chipsets, I mentioned this, have been announced already. And then it's a matter of time until the infrastructure components will support this as well. Performance validation is ongoing as part of these 5G ACIA testbeds, but also there are other testbed initiatives and activities. Also in the process industry, big players already have deployed already 5G networks and are trying it and optimizing it. And also the ecosystem has to grow, and that simply takes time because we have to start from scratch. What we're currently doing at 5G SAA is we are working on device certification to address the specific needs of the industrial domain and to see who can actually do that. So we don't have the ambition to do the certification ourselves, but we want to make sure that we have a certification framework in place that addresses all relevant needs. Holistic integration optimization is always important. Mentioned OPC UA, TSN already. Now we are also more looking into edge computing and also artificial intelligence. So how to bring these different building blocks together. And of course, at the end of the day, we also need sustainable business cases. And that's something that everybody has to do on its own to see what is really the benefits that 5G can bring. And of course, what are the costs for a particular deployment. So that's almost the last slide. So we looked already at the long-term development, because now first discussions are starting on beyond 5G, and some already are talking about 6G. That's still far away. So we start now with in the academic community, but still we wanted to make sure that even at this very early stage, it's going into the right direction. So that's why we put together 10 points that we think are important from the perspective of 5G SAA. I will very briefly go through this. Of course, the vertical industries with manufacturing, the process industry being a key part of it, should be in the focus even more than with 5G. Also, these non-public networks should stay in the focus and should be supported in the best optimal way. So call it non-public networks 2.0. Somehow related to this, there is certainly a need for sophisticated self-management so that we can achieve a high level of resiliency, for example, and also that it's getting very easy to operate such networks. And artificial intelligence, for example, may play an important role here. We need backwards compatibility, especially in the process industry, very important, so that we invest today, that we can be sure that we can build upon the investment also in 10, 15, or 20 years from now. Also then the flexibility, modularity, no factory, no plant is like another one. There are always specific needs and requirements. So ideally we have a highly flexible, modular 5G system that we always can easily tailor to our needs for a particular deployment. Of course, there are also advanced quality of service requirements. There are applications where we could use even lower latencies, higher reliabilities, or higher positioning accuracy. So that's certainly important as well. Open interfaces and full virtualization. There's an ongoing development towards Open RAN, for example, so that also the radio access network is becoming fully virtualized, which has certain benefits in increasing the flexibility, but also basically opening up the value chain. Additional functionalities are being discussed so that in future a 5G, or maybe at some point we call it a 6G network, cannot just connect devices and locate devices, but also do some integrated sensing. For example, integrated radar functionality or imaging, spectroscopy. And there are many things then that could be done with this in the industrial domain. Sustainability and efficiency, of course, are key goals also here for the long-term developments. And we should still think about making it as easy as possible for vertical industries and especially the industrial players to get directly engaged in standardization and regulation. So if you're interested to get further information, please feel free to visit our website, 5G-ACIA.org. There you also have access to all 3 white papers that we have published so far. And of course, everybody's welcome also to join us. We really want to bring all relevant players together. And some, of course, are still missing. So happy to welcome you in future. And also would like to do some promotion here. We are running currently a series of web seminars. The first one took already place, which was an overview presentation similar to the one that I've just given just now. But there are 3 more coming up. The next one will take place tomorrow on the integration of 5G with TSN. And then we have 2 more on digital twins and asset administration shell, going into more detail what I just presented today, and also this exposure of 5G capabilities. Participation is free of charge, of course, and you can register on our website. And with that, with some delay, apologies for that, but I'm done with my presentation. Thanks a lot for joining, and I would be happy to take any questions.
Thank you, Andreas, for this extensive overview. We have 5 minutes left, so let's talk about a few things. Now, we talked about all the benefits, the how it helps with modularization, standardization, and how it's very flexible. But can you concretely say, where do you see the biggest opportunity for 5G, especially, applied to the process industry? Where will the customers get the value quickest?
Yeah, thanks. I mean, that's, of course, one of the key questions, right? At the end of the day, as a manufacturer, you want to see a positive ROI and you want to see it in a reasonable time span. I think in general, we can say, at least from what I personally have seen, so in most cases, it will not be a single use case justifying the investment in the infrastructure and a change of technology, but you always have to look at a variety and combination of different use cases and application. And then we have the potential, for example, with the convergence that I mentioned before. So today, maybe you're using Wi-Fi for one application, wireless HART for another one, and maybe wired communication for a third one. And there's this potential to converge and to replace all by 5G, at least in long term. So it's always a combination of use cases. And then we will see basically an evolution. So we will not start with the most fancy ones for productive usage, most fancy ones being then really this extremely critical communication with lowest latency, highest reliability. We will more start, first of all, maybe connecting mobile devices and portable devices, mobile control panels, augmented reality glasses, automated guided vehicles. So use cases where we need wireless whatsoever, and where 5G then can provide the reliability and the availability and so on that we want to have in many cases. So I would say mobile devices, portable devices, I had this at the beginning, and also retrofitting, of course, another very big topic, and the wireless sensors. And I think all of them are very relevant, especially also for the process industry.
And you just mentioned it. I mean, we're now in the phase where we see the early adopters taking the chance to experiment, maybe to upgrade a part of their plans. So when do you expect a more widespread adoption of 5G in the process industry?
Yeah, also that's a very good question, of course. So from my perspective, the basics are there once we have release 16, and not just a standard, but really the products, the chipsets, modules, infrastructure, and also industrial automation components. Now we will see the first release 16-based smartphones coming out later this year. So it's not so far away, but then it takes some time until the ecosystem grows, until sensors are produced, for example, that integrate 5G, until the routers are available based on release 16. So that simply takes some time. But I would say, let's have a look at the end of 2022, 2023 at some point, and then it will start. But it will not be a step function, of course, so that from one day to the other, all factories will be equipped with 5G. We will still have the early adopters, and then increasingly, a large number of companies will adopt. And that's the natural evolution, of course, that we have. But my personal projection would be end of 2022, 2023 then. So this will mark the beginning of the market, and also, of course, of all the opportunities that are associated with this.
So real quick, we have about 1 minute left. Give us your recommendation to everyone watching us right now, thinking about developing a 5G strategy. What would you recommend?
I think the most important aspect really is to not wait and then hope that once everything is there, you can just pick it and use it. So I really would recommend everybody should think about a 5G strategy for the company, whatever that means, right? But understand early on what 5G can do, what it can't do, and it can do things really in a disruptive way somehow. So offloading intelligence from a device to a local cloud, closing control loops over the air, edge computing being integrated, positioning being integrated. You can really do fancy things with this, and you have to understand it for your business, basically, what you can do and what not. So therefore, learning this, understanding this early on is really my main recommendation. And then you can still come to the conclusion, okay, it's okay if I still wait 2 more years, but you should think about it now. So don't wait, start getting active now.
Don't wait, and don't wait to maybe also get in touch with you, get in touch with 5G ACIA to learn more, to exchange experiences. There's a lot to be done. You said there's a lot of more work that will come. It's certainly a revolution, especially for the process industry. So we're looking forward to hearing more of 5G ACIA, and maybe we'll speak again at Achema 22 in April next year to see what the developments are. Thank you very much for taking the time, Andreas.
Thank you. Thanks for having me.
All right. Take care. Have a good day.